Okay, so we have the sequence 1 minus 1, 1 minus 1, etc. And I've gone ahead and graphed it here. If we want to go ahead and put a formula to this sequence, we can call this sequence, maybe we can call this sequence Ln. And, okay, I'll just put curly brackets around that. And in this particular case, let me just write a formula for the nth term here. If the first term, if we have L1 is equal to 1, L2 is equal to minus 1, etc., then the nth term is equal to minus 1 to the n plus 1 power. And as you can see here, this sequence bounces back and forth between 1 and minus 1. And every time that I ask people what they think the limit of this sequence is, if it's a group of people, then usually in the group somebody will say, well, yes, the sequence converges and there are two limits. And actually, based on what we've talked about here, this sequence doesn't converge to a limit. And so, in fact, we can see that using the language of tolerances. And so, what does this language of tolerance tell us? Well, what I wrote here, there's no number L where the sequence stays within every caller. And so here, let's split this into cases if we're going to think about this, showing that no possible number works here. So consider L equals 1, okay, and so if we're going to hypothesize that the limit equals 1, then we need to find, well, let's see, if we're thinking about the tolerance game, we need to fix a tolerance. So let's just let our tolerance be, say, 1 even, and now we need to find a caller of width 1. Okay, so let me go ahead and sketch that in here. So here would be my caller of width 1, right? And I need to find some position in the sequence for which the entire tail of the sequence will lie within this pink collar that I've shaded here. And it's clear to see that because the sequence, every other term is going to bounce out of the collar, then there is no position in the sequence for which the tail, in other words, the rest of the sequence after that position, will lie in the collar. Okay, and similarly, if we pick L to be okay, so similarly, we could pick L equals minus 1, and play it the same game. But in fact, we can kill a lot of birds with one stone here if we just say if L is not equal to 1, right, then fix a tolerance equal to, and let's just say L minus 1 over 2. So this is a little bit of a trick here. And what I'm gonna go ahead and do is put in red. I hope this is contrasting enough. If L is not equal to 1, so let's suppose that L is, say, right here, right? And if L is not equal to 1, then what we'll do is we'll just fix the tolerance, which is half the distance between L and 1. And then, okay, so, all right, so this tolerance is colored red above. Okay, and the collar associated with that tolerance is colored red. And similarly, what we find is that all of the sequence elements with odd n have Sn not being, so maybe I'll write it this way. Sn for all odd n is not in the red color. Right. Okay, so why didn't I just pick L equals minus 1? Well, I could have picked L equals minus 1, and I would have gotten the analogous picture, but I need to show that for every number L, the tolerance game doesn't work. And so this second statement here that I've written down will actually encompass that all other L's. Let me go ahead and number these. So first, we're considering L equals 1, and second, we're considering if L is not equal to 1. All right, so let's move into thinking about the phrasing here if we have the limit of a sequence equals positive infinity. And so if we're thinking about tolerances, so first of all, there is no number L that for which this sequence converges. So I just want to point out here that this is a special kind of divergence. Right, so the divergence that we just looked at with a sequence that bounces back and forth between 1 and minus 1, that is not, we would never say that the limit equals infinity. So just because a sequence diverges does not mean that the limit is infinity. So when we write this, we're using some shorthand to describe kind of how a sequence diverges, give a little more information about how that's happening. So it turns out if we mean that the sequence approaches infinity, and here we've written plus infinity, what we really mean is that the sequence is growing and growing and growing without bound. And so one way to say that is we could say for all real numbers, and so let me go ahead and just assign a name. So for all m, for all real numbers m, the sequence eventually is always larger than m. And so another way of saying that is that, right, so we could think about m as being some positive number, right? And what we're trying to say is that if the sequence is going to infinity, what we mean is that for every real number m, there is some position for which the tail of the sequence lies above m. Okay, and let me just go ahead and block that off here. And so in particular, you can kind of think about this as a collar around infinity. It's one way to think about it, right? But I don't want you to get confused and think that infinity is like an actual point that we are considering. So just bear in mind that we use that language, and part of that language is coming from the fact that you can talk about it is coming from the fact that you can kind of think about it as a collar around infinity, although technically speaking what's happening is the sequence is diverging. So okay, that I didn't want that to get too technical or too complicated. So as long as you can kind of see what's happening here, that there's always a position after which the sequence is above any real number, then that's the main point there. You can come up with a similar definition for the limit of the function being negative infinity, and I'll leave that to you to write in your own notes. So those are the main points that I'd like you to have from the section on sequences. Some of this is presented a little bit differently than the textbook. The textbook is very formulaic, and I would like you to also focus, I think a large part of what's useful about this material is focusing on the geometric aspect and what's happening with pictures. I think that gives a really good additional perspective, and it's something that we'll be using over and over again as we move into series. So please ask me if you have any questions, if there's information or questions that you have about the reading, then also feel free to ask me those. I have a forum set up on the Moodle site, so feel free to either email me or post questions to the forum on the Moodle site, or drop in on office hours. So I look forward to hearing from you, and I will touch base with you all soon. Have a good night.